Hi folks, this is lesson 2 in our set of videos on trig functions aimed at A-level maths students who are in year 12. If you haven't watched lesson 1 first, I would recommend you start there. It shows you how to sketch basic trig graphs. Let's begin with a starter, see if you can remember any of that first video. Try to do this without going back and looking at your notes, see if you can do it from memory ideally. I'd like you to draw the graphs of y equals sine theta, y equals cos theta, and y equals tan theta. These are just sketches, not plots, but try and make them look as neat as you can. And that's in the interval minus 2 pi to 2 pi. Press pause now, have a go, and then we'll review and see how you did. Okay, so this is what you should have done. Hopefully you remembered that if you're going from minus 2 pi to 2 pi, the best thing to do is to divide up the axes into 4 subdivisions. So if we draw our x-axis out, we want 1, 2, 3, 4 units there, and then 1, 2, 3, 4 there. That would put our y-axis about here. Okay, this is just for sketching purposes. We're interested in the values that are here, which is pi over 2, pi, 3 pi over 2, and 2 pi in the positive theta axis. This is our y-axis up here. So this would be minus pi over 2. This will be minus pi, minus 3 pi over 2, and then minus 2 pi. There we go. Now a graph for sine theta, the maximum value we'll have is 1, and the minimum value will be minus 1. Hopefully, again, you can remember that sine theta is, sine 0 is 0, so we give this our starting point down here, and then we're going to go up to 1, back to 0, down to minus 1, back up to 0 again. So this gives the sine graph looking like that. If we continue that on in the negative x-axis, there we go. Okay, so there's y equals sine theta. Let's do cos theta. So we've got pi and 2 pi, minus pi and minus 2 pi here. 1, minus 1, this is theta, this is y. This time cos of 0 is equal to 1. So we start off up here, down to 0, down to minus 1, back to 0, and up to 1. So we get this kind of a shape. And that's reflected in the y-axis. So it looks like this. There's our graph of y equals cos theta. Let's do tan over here. 1, 2, 3, 4. Going to have a bit of a bigger y-axis. 1, 2, 3, 4. Again, there's pi. There's 2 pi. Let's mark off pi over 2. That's a useful value. And 3 pi over 2. On this side, minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi. Remember, the tan graph has got some asymptotes. So we've got asymptotes at minus 90 or minus pi over 2 and 90 degrees here. There we go. So our graph comes from negative infinity through 0 and up towards infinity. And then that pattern repeats every 180 degrees, or if you like, every pi radians. So we get something like this. It's hard to draw with an Apple pencil. And the last one looks like that. Okay, so there's our graph of tan theta. Hopefully that makes sense. Okay, so last lesson we looked at sketching the graphs of sine, cosine and tangent. This lesson we're going to look at sketching some simple transformations of these graphs. Most of this work should be really familiar from the work you've done in Year 12 and from the work you did at GCSE. Let's start with transformations of the form y equals f of x plus a. And note the plus a is outside of the brackets. So hopefully you can remember what that does. We're going to get a translation in the y direction. If you like, we could write it like that with a translation vector. So no movement in the x direction and a shift in the y direction of a. Looking at some trig graphs, well, the first graph I want to draw your attention to is the red graph. That's the graph of y equals sine x. It should be really familiar. The next graph I drew was the graph of y equals sine x plus 1, and that's drawn in green. Hopefully you can see that we've got a shift upwards. So the red graph bit has been shifted up 1 unit up the y-axis, and that gives us the green graph. Then if we look at the graph of y equals sine x minus 2 and compare that with the red graph, hopefully you can see again it's been shifted down the y-axis by 2. So a nice and easy translation for us to figure out there. Okay, let's look at transformations of the form y equals f of x plus a. This time the plus a is inside the bracket. This is going to give us a translation again, this time in the x direction. What we get is that if we've got plus a in the bracket, then the graph will move to the left by a. So red graph again is y equals sine x, and the green graph is the graph of y equals sine of x plus 45. And hopefully you can see that every single graph every point has been moved to the left by 45 degrees. So we can see, looking at these points in particular, we've got a shift to the left of 45 degrees. Okay, transformations of the form y equals f of ax. Note again that a is inside the bracket. This time we get a stretch with a scale factor of 1 over a in the x direction. So I've drawn the graph of y equals sine x in red again, and the graph of y equals sine 2x is drawn in green. If we look at the space it takes for one full cycle of the sine graph, there, we get one full cycle in 360 degrees. Note that on the green graph, the graph of y equals sine 2x, we get 2 full cycles of the waveform in that same space. That's a good way of figuring out how to draw it. The graph of y equals sine 2x has 2 full waveforms in the same space where it would be one waveform of the graph of y equals sine x. And equally, if we did the graph of y equals sine 3x, we'd need 3 full waveforms. The graph of y equals sine a half x, you only get half a waveform. Okay, transformations of the form y equals a f of x. This is our last one. So basically again we get another stretch, but this time in the y direction with a scale factor of a. So if we look at the graphs, the red graph is y equals sine x, and the green graph is y equals 3 sine x. So hopefully you can see that this point here, this point here, there it is, it's been stretched. It was the point 91 and now it becomes the point 93. It's been stretched in that y direction. Let's have a look at a few examples. Start with example 1. On the same axes, sketch the graphs of y equals sine theta and y equals sine theta plus 2 from theta between 0 and 360 degrees. So if we think about the y-axis, sine theta would normally go from 1 down to -1. The plus 2 is going to move everything up 2 in the y direction. So we need to make sure our y-axis will get up to 3. So sketch your y-axis out here. And we need that to be 3, 2, 1, 0, -1. Okay, so then we can draw a y-axis out. Sorry, x-axis. And we want to go from 0 to 360 degrees. So 1, 2, 3, 4. That will take us to 360, 180, 90. Let's start by drawing the graph of sine theta. So sine theta, sine of 0 is 0. So we're going to get something that looks like this. There's y equals sine theta. Change colour. So the plus 2, as I said, yeah, is going to move everything up the y-axis 2. So this point here, 0, 0, goes up 2 and becomes 0, 2. The point 91 becomes the point 93. 180 becomes 182. 270 -1 becomes 271. And 360 becomes 362. So our new graph looks like this. There we are. Y equals sine theta plus 2. Example 2. On the same axes, sketch the graphs of y equals cos theta and y equals cos 2 theta. This time in radians, from theta is -2 pi to 2 pi. Okay, so let's have a y-axis to begin with, and an x-axis. And we want to get to 2 pi, so that's 1, 2, 3, 4. Pi over 2, pi, 3 pi over 2, 2 pi, minus pi over 2, minus pi, minus 3 pi over 2, and minus 2 pi. So there's our theta axis, there's our y-axis. And we're going to go from 1 to -1. So let's sketch cos first of all. Remembering that cos of 0 is 1. So we're going to start up here, come down to -1, back up through 0 to 1. And it's a reflection in the y-axis. So we get something that looks like this. Close enough. So there's our graph of y equals cos theta. And we change colours to green. So cos 2 theta is going to give us a stretch in the x direction by a scale factor of 1/2. Or if you, the way I think of it is that we need to get 2 full cos waveforms in the space where we had 1 before. Now, we've been quite crafty here because we've used 2 squares for every subdivision, so that means we can easily cut these in half. So we're going to come here, here, like this. There will be 1 full cos waveform. Back down, back down, and up again. So it's going to look something like this. We're just going to mirror that in the y-axis. Down. Back up again. There we go. Okay, so the green is y equals cos 2 theta. Hopefully that makes sense. On the same axis, sketch the graph of y equals tan theta and y equals tan theta minus 45 degrees from theta between minus 180 and 180. There we go, so this is going to be 180, that would be our 90. There's our minus 90. There's our minus 180. So tan, as you will remember, has got asymptotes at minus 90 and 90, so it gives us this kind of a shape. We can carry that on. There we go, there's our tan graph. See if we can get a different colour. Okay, so tan of theta minus 45. The minus 45 is going to move our graph to the right by 45 degrees. So everything's going to get shifted to the right. So if we draw asymptotes to the right by 45 degrees to begin with, and we can start plotting out some points. So it's going to cut here, and we're going to get this shape. And again, it's going to come across, it's actually going to touch at 180 plus 45, so 225. So we'll draw that up like that. And we need to come back a little way. In fact, it'd probably be worth going back to minus 225, putting that extra asymptote in just so we can see what's going on. So we're going to get this. There we go. So what have we got then? We've drawn the graph of y equals tan theta minus 45 degrees. Now, strictly speaking, you could go back and rub out the bits that we don't need. So if we went and found a rubber, we could chop off this bit here that we don't really need, but it was really helpful to have that there just to draw the graph. Okay. Last example, example 4. Sketch the graph of y equals minus 2 cos theta plus 1. Theta is between minus 180 degrees and 180 degrees. Okay, so this is slightly different, but I think we're going to have to draw a few graphs to get us to the point where we can confidently get the graph of minus 2 cos theta plus 1. Let's have, okay, a blue pen would be good actually. So let's draw some axes, but again, we need to think about the size of the y-axis. We know that the maximum value for cos is 1 and the minimum value is minus 1. We multiply through by minus 2. We're going to have to go up to 3 at some point. So we need to make sure our axis will reach up to 3 in the y direction. 1, 2, 3. Minus 1, minus 2, to go all the way down to minus 3. So there's a set of axes. Okay, so 1, 2, 3, minus 1, minus 2. We might need minus 3, you never know. And then Now subdivisions in the x-axis, or sorry, the theta axis. This is why we need to get to 180. So we just need two of these. That's going to be 90, 180, minus 90, minus 180. So let's start by drawing a cos graph. Cos of 0 is 1, so we get this shape. There's a graph of y equals cos theta. Then let's think about what effect the minus 2 has. So if we multiply all of the y values by minus 2, where it was 1, it's now going to become minus 2. The zeros are going to stay the same, and the minus 1s are going to become positive 2s. So now we get a shape that looks like this. There's the graph of y equals minus 2 cos theta. And then what does that plus 1 do? That plus 1 moves everything up another 1 on the y-axis. So I'll get a red ink for the last one. So all of these points that we've just drawn need to get moved up 1 in the y. So we're going to be there, up 1, up 1. We're going to get this shape, don't we? So finally, there is the graph of y equals minus 2 cos theta plus 1. So here are some questions for you to have a go at. Take care, use squared paper, pencil, try and make a really neat job of it. And if you've got any questions, by all means get in touch. Bye.